So we want to be able to understand limits from an algebraic perspective, but we also want to make sure we understand from graphical, which is probably the easiest way, and then with tabular limits as well, okay, on a table. So again, it's important to understand that limits are not what's happening at the point. Okay, so if I want to know what's happening at x naught, that's not what a limit is for. Okay, it's what's happening as we approach x naught here. So we want to find out the limits. If we want to find out the limits here, so if we have the limit as x goes to x naught from the left-hand side, okay, so I'm going to do this in a different color here. Let's do that in red. From the left-hand side, okay, that means we're coming at it from this side. Okay, now what's actually happening at x naught is that it's equal to b. But as I approach it from the left-hand side, it's not going to be equal to b, it's equal to a. As I approach it from the right-hand side, okay, so this is my limit from the right-hand side here. Okay, so as x approaches x naught from the right-hand side, it's going to be equal to b. Okay, so it's looking like it's equal to b. And the actual value at x naught is equal to, it's in fact equal to b. Okay, but that's not what a limit's for. The limit doesn't tell me what's happening at x naught, although it happens to match the limit of the positive coming from the positive side. That's irrelevant for the limit. So when we talk about a two-sided limit now, as a two-sided limit, the limit as x goes to x naught from both sides, well, it's not approaching from the same point from both sides. We say that the limit does not exist. Okay, so we write DNE for does not exist. So this is what we call a jump discontinuity. This one is here, if we take a look at it, it's this parabola coming from one side and then a straight line coming from the other side. So we want to know what's happening right at x naught. So at x naught, as I come from the negative side, okay, as I come from the negative side here, it looks like it's equal to a. Okay, so that's what's happening from the negative side. If I want to know what's happening from the positive side, okay, I have to look at the graph and see what's happening from the positive side here. From the positive side, it's approaching that same value, a. So that's equal to a as well. When I talk about the actual coordinate at x naught, well, it's actually not equal to either one of those. It's not equal to a. It's actually equal to 0. Okay, so there's my actual x naught coordinate. But again, limits have nothing to do with what's actually happening at that point. What's more important for limits is what's happening as we get arbitrarily close. And from the left side, it's equaling a. From the right side, it's equaling a. And as a two-sided limit, it also equals a because it's going to the same point from both sides. Okay, and again, the fact that it doesn't end up at a is not really the limit's problem. Okay, the limit's only telling us what's going on as we get arbitrarily close to that point. So when we say that the limit only exists if the left and right hand limits are both equal. So in this case here, C, the limit exists because the left and right hand side limits are both equivalent. So we need to make sure that we understand how to do it with graphs, with tables as well. So if we take a look at this table, as x approaches 7 from the left hand side, so let's put some more values in here. It looks like it's 24.9, 24.93. Let's say at 6.99, we're ending up with a value of 24.999. Okay, and we don't know what's happening at 7. From the right hand side here, look 7.1, we get 25.1, 7.05, we get 25.07. Let's say at 7.01, we're ending up with 25.02. 2. So it looks like from the left-hand side, it's approaching a value of 25, and from the right-hand side, it's approaching a value of 25. And so the limit as x goes to 7, again, we don't really care what's happening at 7, but as we get arbitrarily close to 7, that f value looks like it's approaching a value of 25. And this is how we evaluate limits. Again, this at 7, it could end up being 58. Who knows, right? But again, the limits are only telling us what's happening as we get arbitrarily close to that value of 7.